So unusually, first off, I'm Brett Morgan. I'm on the Flutter Developer Relations team. I'm based in Sydney, but I spend an awful lot of my time transiting the Pacific Ocean. That's the nature of the job. So what I'm going to be doing tonight is giving you an overview of 6 of the talks that happened, for 1 at Cloud Next and 5 at Google I/O. Now, given the fact that I have, 25 minutes, and each of these talks was 35 minutes to 40 minutes, I'm obviously not going to cover the entirety of the talk. I'm just going to give you effectively a quick insight into what each talk is about, and then give you a link to where you can see the whole thing online because of, we have YouTube. So, just doing the math, I have 150 slides, 25 minutes, it's about 10 seconds per slide. So, kicking off, first talk where I spoke on stage with my boss, Matt. Who here knows what Flutter is? Who's cool? So I can fly through these. Who's actually used Flutter? Anyone here has actually shipped a production app with Flutter? Wow! Get that man a medal. So who here doesn't know what Flutter is? Doing the inverse of all the above. Cool. So the first 5 or 6 slides are about what Flutter is. So Flutter is our way for building native iOS and Android applications. This slide is actually a little out of date, but we'll get to that. So what do I mean by native? One of the things that we do with our material toolkit is we adapt to the platform. So as you can see here in this animation, what we're doing here is doing native things where if you say scroll a list, on iOS you get the overscroll, on Android you get the ink splash. Likewise, when you go into a dialog with iOS, it slides into the side, on Android it comes up from the bottom. These are just things that mean that your user feels at home. Next. Flutter is all about giving you complete control of the entire screen. It's controlling every pixel, so you can have fast, fluid animations. It's all about getting the magical 60 frames per second. 60 frames per second is important on mobile because you're trying to create an illusion with the user where they're not interacting with a piece of glass, but they're actually interacting with a magical portal into the internet. But to do that, you've got to keep 60 frames per second, otherwise you break that illusion and suddenly you drop them out of it, they know they're just sort of poking a piece of glass. The next thing is, Flutter is about making it possible to do more with less. So one of the traditional problems with a lot of software teams are hitting is that they now need like an Android team, an iOS team that knows about Cocoa Touch and Objective-C and Swift, and they need a web team because they need, so suddenly you've got 3 or 4 teams, and I don't know if you're good at coding cats or not, but trying to get 3 teams to agree on a schedule, a set of features, and getting them all implemented at roughly the same time is hard work. Whereas if you have one code base that you're hitting all of your platforms from, suddenly you have one team that's working on one code base, delivering one product. Suddenly it's a lot easier to get sort of coherence in your product suite. One of the great things about Flutter is something that I'm not going to demonstrate tonight called Hot Reload. It's the ability to sit there in your editor, make changes, hit the save button, and have it magically appear on the device. Usually, like for the last year, I've been giving Flutter talks, and each time, half my talk, 3/4 of my talk, my whole talk is done inside of an IDE, but tonight is just slides. Apologies if you're expecting to see me actually coding tonight. Let's get into the platform. This is the tech stack. You're going to see this slide, or variants of this slide, a couple more times, because this is actually sort of core to what Flutter is about. The bottom part of it, the skier, the Dart, and the text, these are libraries that we've adapted and adopted from things like Chrome and various other places. Everything above the dotted line, so Foundation all the way up to Material and Cupertino, all of this is implemented in Dart. This has been a wonderful opportunity for people who've done a whole lot of implementing browsers to re-implement what they built in C++ in Dart, and suddenly everything is a whole lot easier. One thing to point out here is that the entire stack is open source. So yes, you can go and clone the Git repo and have a look and see what we've done. There's no hidden source. The next thing that's I need to point out is that we actually have 2 ways of compiling. And this is the perennial answer to the why Dart question. We have an ability to embed a VM into the device, and that gives us our hot reload capability because we can do a delta on the code. The downside of this is that it's reasonably large. A full development environment inside your phone takes up a fair amount of space, which is why people usually sit there and go, I'm just trying Hello World with Flutter and it's like 40 meg, what's up with that? And the truth of the matter is they've got a full Dart VM, and they should actually just press pass the -- release flag, at which point their app will shrink to about 4.5, almost 5 megabytes. Next, everyone loves developer tools. I don't really want to have a Vi versus Emacs war on me, but what we're going to say is that we support at a premier level Android Studio and Visual Studio Code, but we also have command line tools, and the community are doing a great job of exposing those tools inside of Emacs and Vi and all the other places. Hot Reload, which I mentioned before, Package Manager, which I'll get onto, and a bunch of other stuff. I have to keep moving because I have very limited time. So just to give you a flavor of what Flutter development is about, here's a fairly standard screen that you put inside an application. So it looks nice. How would you implement it in Flutter? What you do is you look at it and you go, it's actually a vertical column. So that's where you start. An awful lot of Flutter is about creating lists of things. So we have this column with an image in it, and then a title section, and then some buttons and some text. Let's actually dive into the title section so you can get a feeling for how we actually implement it. It's horizontal, so we just turn that around, and instead of a column, we have a row. And inside that, we, strange enough, have another column, which is where we've got the text one above the other, and then so on and so forth. So you get this sort of cascading in rows and columns, stacks, and there's a variety of other ways of laying things out, but rows and columns really are where you start. What widgets do we have? We have the material widget set. So the material widgets are the ones that you know from Android, but as I'll get to later, material is really meant to be cross-platform. But for those people who want to do something that feels very much like iOS, we also have a set of Cupertino widgets, so there's buttons and sliders and all sorts of things. So this is really to answer the question of how is it implemented. It's actually a Flutter View controller or a Flutter View inside of an activity. There's a bunch of stuff here for those people who want to add it to an already existing app. If you want to dive into this, come and talk to me after the break. One of the really cool things about having a very active community is that we also have a thing called pub.dev. And this is a naming convention you'll see me use a bunch tonight because we just launched a bunch of new websites. I need to actually update this screenshot. It's gone a whole bunch darker than this. Pub, because of programmer humor, the original program was called Dart. Where do you play your darts? Pub, makes sense? Cool. So Pub is our collection of packages. So there's you use Pub to install your dependencies, and we've got, as you can see, a whole bunch of things there for maps for Flutter and so on and so forth. And the important numbers, yes, it's all MIT licensed, BSD licensed, it's open source, it's all up there on GitHub. If you want to see the whole talk, where I also stand on stage and implement a Google Maps app inside of Flutter, there's the link, bit.ly Flutter Google Maps. Moving on, now we're on to I/O. So the first one is, well actually there's two talks called this because tracks and naming is hard. So the first one is Beyond Mobile. This is the Emily's talk. And Emily's talked in a very world-breaking fashion. So they talked about how everything is growing, and of course Flutter is growing. Started out on mobile, it's going to desktop, and of course the announcement about Flutter Web. So we'll get into a little bit of that, but if you want to know more about Flutter Web, grab me in the break. iOS and Android, this is really where Flutter started. It was really about, when it started, how do we make mobile web development quicker and easier and 60 frames per second. So it's all about making beautiful apps. And here's a wonderful animation of the thing I'm not showing you tonight, which is Safe for Hot Reload. This is the one that usually breaks most new developers, because you're sitting there and you're, say, 5 pages into that shopping cart and you've added a whole bunch of things to your cart and you're trying to tune what the shopping cart looks like. And to move something down, you now need to reload your app and add the items, and it gets really painful. Whereas with Hot Reload, when you make a change to the screen, you don't actually lose your state. So you've still got all your items in the cart, you can start moving things around the screen. We call it painting the UI. It's a lot of fun to do. So I mentioned that you're going to see this, the architectural diagram a bunch of times. So this is the traditional Flutter, where you've got your framework, you've got your code sitting above it, then you've got a C++ engine, Android and iOS runner, and then the hardware. So that's what Flutter was traditionally. But we're going to come somewhere else. there's actually 3 different ways that Flutter addresses the desktop, each with different strengths. So the first way is, I don't know if you've heard it, but Chrome OS now has the ability to ship Android applications. It actually uses something called Arc++, which is basically the Android runner on Chrome OS. So yes, you can turn around and ship Flutter. You can actually do development of a Flutter app on a Chromebook and ship it to the same Chromebook, and then your Chromebook gets really, really hot. There's another way of doing desktop development, and this is the one I'm actually enjoying. This one's very much in development. It's basically, as I said before, Flutter is, I think I've probably got a diagram for this, yes I do. So we've got Flutter, which is designed really for, okay, give me an OpenGL context, I can paint it. And so what you can do is, using say GLFW, you can expose an OpenGL context to Flutter, and then suddenly you can run Flutter apps natively on macOS, or Windows, or Linux, so on and so forth. Again, open source project, it's now got the ability to do hot reload of Macintosh applications. This is what I do for fun. Finally, one of the big announcement in the Emily's talk is Flutter for Web Technical Preview. So this is where, remember that stack where we had like native stuff and Skia and all that stuff? We basically ripped out Skia and we've used the Dart UI layer to re-implement the bottom half of the stack using HTML primitives, so divs and canvas and all sorts of DOM fun. They're actually using a whole bunch of advanced CSS features. So this gives you the ability to write code once and have it appear in a whole bunch of different places. This is currently a technical preview, so I wouldn't suggest going and running your bank on top of Flutter for Web. But if you're running like a weekend experiment, turning around and putting it in Flutter for Web and seeing what breaks and raising bug requests, totally brilliant thing to do. Our team will love you because you're helping us find bugs. Okay, and that's the process. You write your Flutter code, and we use 2 different things. We use Dart2JS for effectively the equivalent of the ahead of time compilation. We also use a thing called DDC, which is a quicker to compile, but it winds up generating more JavaScript. So we effectively have the same split that you had on Android or iOS, where you have a virtual machine development experience and a ahead of time compilation. Okay, if you want to see the whole talk by the Emily's, Flutter-Beyond-Mobile. The second talk, called Beyond Mobile, but this one is about material components. So the thing I want to point out here is that material components is probably our premier widget toolset. It was designed by Google as a way of not just Android. A lot of people think of material as just the Android UI toolkit because that's kind of where it appeared first. But it is really designed for being able to use 4 applications across the web, Android, iOS, desktop apps. So one of the things that we did, not this year, but last year, is introduce a thing called material theming. Let's dive into why. So 2 years ago, I think, when material first appeared, a whole bunch of Android developers went, oh my god, this looks really cool, and went and wrote a whole lot of applications that all looked almost identical. Because material didn't give you enough enough ways to tune it so that you got your own character. So we fixed that a year ago by introducing a thing called material theming, which gives you the ability to start tuning your material app by adding a theme so that suddenly your brand, it's your feelings, your colors, it looks like you. Now, one of the problems is, of course, once we introduce theming, Google turned around and, of course, having a whole bunch of designers made a good Google material theme. And a whole bunch of developers out there went, oh, do we have to make our apps look like that now? It's like, no, you're holding it wrong. What you're meant to do is make it look like your company. And what we're doing here, if you have a close look, is that all the material themed Google apps actually reflect Google. So we have primary colors, we have lots of white space, it's kind of playful. You might be a finance institution, suddenly those light blues and very serious tones are much more appropriate. Or maybe you're playful and so suddenly bright colors are more appropriate. Yes, use theming to express your brand. Material design loves Flutter. Why is this? Because Flutter gives you the ability to turn around and put themes at the top of your app, right in the material app, and you can turn around and tune everything here, like app bars and what buttons look like and what so on and so forth. Let's dive into that. Oh yeah, what does theming really mean? It means making things consistent with your brand. So let's have a look. So we've got a card theme here. What we're doing here with this card theme is going, cards will all be rounded. But not just cards need to be rounded. You can turn around and also say, round all your dialogues. Now, traditionally, dialogues inside a material are quite square. They've got really sharp corners on them. They've got a nice little shadow behind them. But you can turn around and take advantage of the fact that we're running an OpenGL, do all sorts of crazy fun things. And the big announcement in this talk was, well, not this talk specifically, but at I/O for material, was that we've now got dark themes. So that gives us the ability to do, say, the Basil app, but dark. So the nice thing here is that in the material app, we now have the ability to expose both a theme and a dark theme. Thus, when you're, I believe it's the latest rev of Android now has the ability to flip between light and dark at a certain time of night, your app will adjust. And that's the power of that. Also, some bunch of new widgets, taking the traditional material slider, and here's a way that you can turn around and theme it. So we can turn around and set the thumb shape, and here's how you implement the diamond thumb shape if that's what how you want to express your brand. Another thing, everyone loves button nose across the bottom, but it turns out that some people wanted the ability to get rid of the labels, so now we have the ability to have no labels, but fair warning, work with your UX people and make sure this is actually appropriate for your users, please. Another thing people asked for was the ability to animate the floating action button, so we've got that. And of course, everyone's starting app is the to-do app. Now we've got the ability to drag things around inside so you can appropriately prioritize the tasks that you are going to do. Another thing we've got range sliders, and they come in both continuous and discrete. And of course, if you go and watch the talk, we talk about how to implement a nice pop-out, expandable search. How much of your time, by the way? I've got to keep moving. Cool. The next talk is Pragmatic State, and this was by Matt and Philip. So why state? One of the great things about Flutter is that it was originally designed as a Flutter UI toolkit, which meant that we didn't really care about state because we were being good engineers and focusing on the problem we were trying to solve. And a whole bunch of people came to us and said, no, you're not a UI toolkit, you're an application SDK, right? So you should care about where the state goes. So we're turning around and figuring out how to do state well. So the traditional starting point is that you come up with a napkin sketch for your application, and it's fairly obvious how to turn that into an application. You've got a bunch of text, some icons, an inkwell for reactivity, and a clip rectangle, and so on and so forth. That's pretty cool, right? The problem is when you actually get to the point of when a user clicks on something, you've got to react to that and change your state as a result of that and give the user that illusion that you're actually having a conversation. So how do we do state management? Well, there's the UI state. Then there's a whole bunch of business logic that you react to with that UI. Then there's some network and some disk and pixels, and yeah, it's actually all of your problem. You have to solve all of these things at once. So let's take a toy application. It's probably a little small to see, but the part that's actually growing is the state management. And so let's have a look at how this app is built. Here's the naive approach. You have an app that has two widgets underneath of it, a chart widget and a slider widget, and when you tap the slider, it sets states on my chart. It's kind of bad. You've got strongly coupled widgets, so you don't have the ability to reuse. You have global state, and we all love globals, and yeah, it's all kinds of nasty. So there is actually a thing that we're trying to do with this Reactive Framework, is that we're looking at UI as a function of the state. And that's your build methods. Make sense? So how do we actually get this to work given the fact that we're trying to make the UI a function of the state? Well, the first thing we do is we pull out the state. So when you tap on the screen to move the slider doesn't talk to the my chart directly with set state. It actually talks to your state at the top of the tree to turn around and say, I've slid the thing. That then updates the chart updates, and it also updates the slider so that the slider moves. So how do we do this in a pragmatic way? So originally we used to promote a thing called scope model. Scope model is good. We also talked about a thing called block. I think even I spoke about block at one point. The problem with block is that it is a reasonably large hammer. It's quite complicated, and it was designed to manage state inside of a very large application. It's probably over-engineering for the apps you guys are going to build in the near future. What we suggest is you start with something that's a little bit easy to get your head around. It's actually been developed in the community. It's called Package Provider. So a wonderful place where you can see this used is this little application here, released by 2D Inc. It's actually a gamified version of software development. So if you've ever had to try and explain what you do to your parents, get this game and you can have them hooked for like at least 10 minutes. So what we're saying is to make that application, make it rapid in provider. And you can see it all live coded on stage by Matt and Phil. Flip. Okay. This was the talk I was in at I/O. This is about Cupertino widgets. So while we're having the talk, we can do iOS development using Material. Well, the kind of downside of using Material is that sometimes users expect things to look like iOS when you're on iOS, and they get a little bit cranky with you if everything looks like Android. So we've got multiple ways of making our users happy. So at a start, Material does actually adapt to the platform where it can do the obvious right thing. So obviously in the case of lists, that when you pull down, we do the right thing. The text at the top of the screen is centered on iOS and to the left on Android. So these are things that are obviously correct by platform. But there are times and places where it's up to you, the developer, how far you want to go. So in a simple case, maybe you want mostly Material, but just a little bit of platform specific, i.e. you might want to use, say, the Cupertino style button or slider, just to make it a little bit more iOS. Other times you want to do a majority of the application looking like native, but just have a little bit that's Material. And of course, there's the last option where everything is like, actually it's the other way around. You're just using the native style dialog boxes. So, kind of going to skip through all the parts where I was actually live coding this on stage. There were 5 sections where I live coded. I did like 400 lines, it was insane. But the app looked like this, and that's what we set out to build. I did a drive-through of all the different Cupertino widgets, which you're going to have to see the video for, but there is a bunch there. There's tabs, there's sliders, there's buttons, there's all sorts of fun and games that our team is building. One of the interesting things about Cupertino versus Material is that iOS developers actually have a different way of seeing the world, in that on Android, everything is sort of this single stack, sort of like a web tree, whereas on iOS, when you have the tab bar is always at the bottom, always available, and the pages inside it have their own navigation stack. So we had this application that we built, and there's a bunch of Cupertino widgets inside of it. The app is a replacement for Material app. Cupertino tab scaffold and tab view give you the iOS style tabbing, and then a page scaffold gives you similar to Material's page scaffold. So added a bunch of widgets, actually implemented it. But there's an interesting part when it comes to, if you've got an app that looks at iOS, you want to actually also bring it across to Material. So how do you do that? So the thing you do is you see all these places where you've got these 2 Cupertino widgets, and we actually turn around and use the appropriate one depending on which platform you're on. So Cupertino app versus Material app, page scaffold, and sliders. And I turned around and implemented that. Just skip through this because I'm running out of time. Okay, so there's also one question we get a lot is, how do I turn around and use native capabilities? In this case, we're looking at where's the correct place to store data on the machine, depending on whether you're Android or iOS. And thankfully, the pub.dev community have provided a thing called Path Provider, which you can turn around and ask, where do I store documents? This is actually implemented in Java on Android and in Objective-C on iOS. And we have a plugin system which handles the marshalling between the native environment and the data environment. Let's just skip through this. If you want to go and see the talk, there it is. Okay, last bit, Dart. So this is about what we've been doing in Dart lately. So Dart itself, those of you who actually implemented stuff in Flutter, you already know this, but for everyone else, it's a modern language. It's designed to feel like the sort of scripting languages, so it's lightweight, but it's also got full classes. So it isn't one where you have to implement object orientation by yourself. We provide it out of the box. And the important thing here is, if you have a look, we have the ability to have little closure functions here. So it's actually closing over the bang, which is defined above it. And once we dive into it, we can map over a list using that function, the anonymous function. And that we also have the ability, well, as you can see here, we're not actually defining types. So it's var bang. It actually uses type inference. We'll come back to that. But we can also, when you're exposing a method or some functionality, you can turn around and specify types such that you actually get errors in your IDE. You not have to wait until runtime when your errors turn up in the user and they come and beat up on you because you did the wrong thing by them. We also have generics, unlike some languages that threw them away, which means that this is the world's most useless generic implementation, but let's go with it. So we have a box of type T, it stores the T. You'll notice that the box, this contents, that's actually a constructor. We're doing the usual thing where you're taking some object, some data and putting it into the class. We're just delighting having to do this.contents equals contents. Okay, what we'll also have is the ability to have a method that has its own type parameter, which is different to the type parameter on the class itself, which means that we can turn around and do a conversion. So we can rebox the contents from, say, strings to ints or whatever. Let's actually have a look at how this works out. So this is what it looks like in Java. It's kind of noisy. We can do way better than that. So the first thing is, it's a string. We know it's a string. We don't need to pass that on, so we can just align that type parameter. Secondly, string box itself. Well, we already know it's a box string, so we can just make it more scripty. Now the var. Similarly, num.parse, we know that it returns a number, so we don't need to tell rebox that, which means that we can also turn around and say, we already know that numbox is a box of num. Finally, we know that we've held on to what the type of the rebox type is, so we can get rid of that as well. And suddenly you have something that feels a lot more scripty, but it is just as type safe as the first version. So, lightweight. So, for those people coming across from Java and those sorts of languages, it's a lot lighter on the typing. But we've got full objects, so unlike earlier versions of JavaScript, and we're functional, and we're typed. So there's a whole lot to like about this language. But what did we announce at Google I/O? UI as code. It's a new feature. So one of the things that you are as a Flutter developer is you're basically defining a UI, just lists of, well, it's a bit like this, behind. So we've got a widget here that's building a column, but we're doing some sort of UI, and we don't show the next button when we get to the end of the page. And so how do we do that here? Traditionally, we'd have to turn around and break ourselves out of the nice single expression return and start doing this imperative coding where we turn around and go, well, if we have more content, then we have the next button. We're adding the items. Let's add some sections as well. Well, actually, let's go one further. For each section, let's add the chapters of the section, say. This is starting to look a little noisy. So what we did with Dart 2.3, which we released at Google I/O, is that we gave you the way to do this a different way. So back to where we started. So now we've got an if inside of the list, which means that the traditional thing in Flutter, where you've got to say have a sign-in button when the user's not signed in, or showing a shopping cart when they've actually selected some items, you can suddenly now just do that. Next, we can, stealing a leaf out of JavaScript's book, we now have the ability to just turn around and slide a whole bunch of items into a list. Or even if you're, as we said, the extension where you're taking each section and taking the chapters of that section, you can turn around and do a for over those. So if you have a look, the before and after of the Dart 2.3 UI as code is that we've significantly simplified your Flutter development. What else are we doing? Next is non-nullable types. So for those of you doing Kotlin or Swift, you know about the joys of non-nullability. So one of the motivating example here is try-parse. Try-parse tries its very best to actually parse a number, but in the case where it doesn't actually parse, so not in is not really going to parse as an in, it's going to throw a runtime error, and that's bad. All the time. I told you I had a lot of slides. So what we do is we turn around and introduce nullability. So now we're actually saying this is potentially null, at which point this becomes an error. So how do we get around this? Unlike Swift, we turn around and we narrow the type. When you do a null check, we know that you've null checked and suddenly number is not null, so we can call is even, and it all just works. So there's a bunch of things we're going to do. It's going to be incremental, so we know that everything is going to take time to migrate. We're going to supply tooling around it. And once you have your code and all the code you depend on migrated to non-null, then we have zero reference errors at runtime. This is down to the fact that we're a full stack top to bottom. And of course, once you're fully non-null, we can actually emit better code. Other things that are on the work list, extension methods, again, stealing a belief from Kotlin, concurrency, FFI, so on and so forth. There's the website. So far I've just grouped 3 websites: dart.dev, flutter.dev, pub.dev. I think that's the full collection. And the whole talk is bit.ly/flutter-dart. And I think for reasons of time, we'll skip that. Thank you very much.
Thank you for that presentation. As we are running still a little bit behind time, I think what we'll do is we'll get our next presenter, Zubin, to come and